For today, you will get to learn all about periodic table and its historical development, periodic trends and its different properties of the elements, and all about chemical bonds. So let us first learn, recall the persons behind the historical development of the very useful periodic table. So beginning with Antoine Laurent Lavoisier, Lavoisier, depende kung paano nyo i-pronounce. Basta correct yung spelling, yun na yun. Okay? So, sino si Antoine Laurent Lavoisier? Siya yung nag-made on the extensive list of 33 elements. He was also the one who made distinction between metals and non-metals. So, take note, the one that made distinction, he distinguished metals tsaka non-metals, si Mr. Lavoisier po. Then, it was John Jacob Berzelius who developed the table of atomic weights. He was also the one who introduced the letters to symbolize elements. Okay, para mas madaling matandaan, si John Jacob Berzelius, sa pangalan niya, merong letter A, then letter Z. Remember na yung letters from letter A, alphabetical letters, from letter A hanggang Z. So, he was the one who introduced letters to symbolize elements. Okay, parang mnemonics lang para matandaan. Okay, so Jacob Berzelius. Johann de Beriner naman, Johann de Beriner, sa kanya naman yung law of triads. Okay? Sa kanya yung law of triads. Yung triads, yan yung forerunner of the concept of groups. So, bago pa classify yung mga elements by groups in a periodic table, meron na tayong advanced model for the concept of groups. Yun yung triads. And that was proposed by Johann de Beriner. Okay? Now, in his law of triads, sabi niya, yung average of atomic weights of the first and third member is equal to the atomic weight of the second member. Kumbaga, para sa kanya, sabi niya, say for example, in a group, yung elements, say for example, lithium, sodium, di ba, these elements are on the same group. Okay? Lithium, sodium, potassium. Si lithium as the first element daw in this group, okay? Then si potassium as the third element in this group, kung kukunin natin yung average atomic weight nila, ano ba yung atomic weight ni lithium? Tingnan nyo sa periodic table, di ba 7? Atomic mass ni potassium, 39. Kung kukunin natin yung average ng 7 tsaka 39, okay? Then, i-add mo yung 7, add mo yung 39, divide 2, you will get the atomic weight of the second member. And that is sodium. Okay? And that is 23. Okay? So, 23 po yung makukuha mong average upon adding the atomic weights of lithium tsaka potassium. Kunin mo yung average ng atomic weights nila, yung makukuha mo na sagot, yun yung atomic weight ng second member. Eh, nagkataon nga. Ngayon nga yung atomic weight ni sodium, 23. Okay? Then, for John Newland, sa kanya naman yung law of octaves. So, tandaan ha, Johann de Beriner, sa kanya yung law of triads, Johann Newland, sa kanya naman yung law of octaves. Law of octaves, ito naman yung forerunner of the concept period. So, bago pa classify yung elements via periods, meron na tayong advanced model din, okay, for the concept of period. And yan yung octaves proposed by Mr. Newland. Okay, he was the one who arranged the elements by atomic weight and found out that yung first tsaka ninth elements have similar or the same properties. Then, finally, okay, yung pinaka-known, kilalang-kilala natin si Mr. Mayer tsaka Mendeleev. Si Luther Mayer tsaka Dmitri Mendeleev, sila naman yung nakapag-formulate ng periodic law. Okay? Wherein, yung physical tsaka chemical properties of elements are functions of their atomic weight. So, inarrange nila yung atoms based on atomic masses, based on atomic weights. Yan yung sa periodic law na finormulate nila. Okay? Then, the one who modified. Okay, meron pa pong nag-modify ng periodic table. Yan po si Henry Moseley. Okay, Moseley. Minodify niya yung periodic table, periodic law. Okay? Wherein yung properties of elements daw vary periodically with their atomic number or proton number. Kaya arrange na via its atomic number, arrange based on the atomic number yung elements in the periodic table. Okay? Now, in the periodic table, as observed, again, in the periodic table as observed, yung elements are arranged in horizontal. Meron tayong horizontal. Meron din tayong pa-vertical arrangement. Okay? Yung vertical, vertical. Okay? Now, yung horizontal row, okay, yung horizontal row of elements, yan yung tinatawag natin na period. Okay? So, yung horizontal row, yung mula left to right to left, okay? Yan yung period. Okay? And recall na yung period that relates to the highest value principal quantum number. Naalala? Yung first quantum number, di ba? It describes the main energy level. Okay? And sa periodic table, malalaman natin yung highest principal quantum number, okay, based on its location sa periodic table. So, kung saang period makikita yung element, yan yung highest principal quantum number niya. Say, for example, si aluminum, okay, si aluminum, kung isusulat natin yung electron configuration ni aluminum, okay, yung highest principal quantum number niya is 3. Okay? Kasi nga, makikita sa period 3. 1, 2, 3. Okay? So, yan yung importance ng period ng classification. Then, yung vertical arrangement naman ng elements, mula top to bottom, yan yung tinatawag natin na group. Okay? Yan yung vertical arrangement of elements. So, saan naman related yung group na arrangement? That is related to the differentiating electrons or last entering electrons. So, pag sinabing last entering electrons, we are also referring to the valence electrons. Okay? Valence electrons, ito yung mga electrons that participates in chemical reaction. Now, among representative elements, so pag sinabing representative elements, ito yun. Mula hydrogen, itong grupo ni hydrogen, group 1A, group 2A, 3A hanggang 8A. Okay? Ito. Yun yung mga representative elements. Now, take note, for representative elements again, kung ilan yung number of valence electron nila, that is equivalent to their group number. Okay? Or vice versa, kung saang group sila na belong, okay? Kung saang group, for representative elements, kung saang group sila na belong, that is equivalent to their valence electron, number of valence electron. So, pag sinabing bromine, nasa group 7, ibig sabihin, 7 yung valence electron nila. Nya. Si calcium, nasa group 2A siya. So, ibig sabihin, 2 yung valence electrons niya. Okay, again ha, that is only applicable for group A elements. Okay? Next, let's proceed to the periodic trends. Okay? Okay, again, let us discuss periodic trends showing the different properties of elements. Okay? So, the first property ng element is yung atomic radius. Atomic radius, this is defined as half the distance between two nuclei of two adjacent atoms. Okay? So, yung concept ng atomic radius, okay, dalawang adjacent atoms, kunin mo yung nuclei nila, okay, yung nuclei, then half the distance. Okay? Half the distance between two nuclei. Okay? Ayan. So, yan yung magiging atomic radius. So, for this example, ito yung atomic radius, for instance, ng hydrogen. Okay? Bali, yan yung concept. kunin mo yung half ng distance ng dalawang nuclei. Okay, say for example, ito yung unang nuclei, di ba? Kunin mo yung half part niya, then i-connect mo sa half distance ng isa pang nuclei na ka-adjacent atom niya. Okay, so yung atomic radius, this is related to the atomic size. Okay? Now, tingnan natin kung ano yung trend. Ano yung trend ngayon sa yung periodic trend when it comes to atomic radius. Okay? Okay, say for example, down A group. Okay, punta tayo ha, pa-down ta. Down A group mula hydrogen, okay, mula hydrogen, lithium, sodium. Okay, and the rest. Ano yung mangyayari sa atomic radius? Ibig sabihin, ano yung mangyayari sa atomic size? Does it increases or decreases? Okay, tingnan natin ha. Si hydrogen, pababa ng lithium, ano yung nangyari? Balik tayo, hydrogen, lithium to sodium, di ba? Down A group, atomic radius increases. Why? Bakit siya nag-i-increase? Because, tingnan niyo yung N value. Yung N value, di ba? Yung N value increases. Di ba? This is the first level, second level, third level. So, as the N value, as you go down a group, tataas yung N value. Remember, yung N value, yung principal quantum number, it describes the size. Okay? Size ng atom. That is why the greater the N value, larger yung size ng atom. Okay? So, tandaan, down a group, okay? Increase yung N value. Kaya, atomic radius increases. Okay? Now, paano naman across a period? Ano naman yung mangyayari across a period? Okay? Say for example, from sodium. From sodium, punta tayo pa left, papuntang magnesium, aluminum, silicon, okay, and so forth. Okay, punta tayo across a period ha. Alam na natin yung down A group. Down A group, increasing yung atomic radius. Okay, punta tayo sa across a period. So this time, okay, ano yung nangyayari? From sodium, then magnesium, then aluminum, silicon, phosphorus, sulfur, proton. Ano yung nangyayari? Nagde-decrease ngayon yung size. Paliit yung size ng atoms as you go across the period. Okay? Bakit? Ano ba yung nangyayari sa N value? The same ba yung N value? Yes. Di ba nasa third period lang tayo? Okay? So, same lang yung N value. Same N value. Saan lang sila nag-differ? Ano yung nag-i-increase? Okay? Diba 11 yung protons ni sodium, sa magnesium 12. So, saan lang sila nag-differ? Sa number of protons, ibig sabihin sa atomic number of protons. Okay? So, differ sila ngayon sa number of protons, the same yung N value. Ano yung impluensya ngayon ng number of protons sa atomic radius? Diba yung properties na diniscuss natin ngayon is atomic radius. Ano yung relationship ngayon ng number of protons? Paano siya nakaka-apekto sa atomic radius? So, ganito. Okay. Alalahanin natin na okay, take note ha. Yung proton muna. Okay? Diba yung proton charge, it influences the charge of the nucleus. Okay? So again, if ito yung atom, okay, atom yan. Sa nucleus, di ba sa nucleus, makikita doon yung proton, tsaka neutron. Okay? The reason bakit yung nucleus, ito yung nucleus. Okay? Sa nucleus, again, makikita yung proton, tsaka neutron. Now, the reason bakit positively charged yung nucleus, it is because of the influence ng charge ng proton. Okay? Now, so ano yung mangyayari ngayon? Okay. Across the period as observed, across a period as observed, okay, as we go from the right to the left, atomic radius decreases. Tama? Atomic radius decreases due to the influence of increasing nuclear charge of the atom. Okay? Again, yung atomic radius ngayon, across a period, sulat ko ha, across a period, okay, yung atomic radius decreases. Why? Because increase yung nuclear charge. Okay, nuclear or effective nuclear charge. Bakit nag-i-increase ulit yung nuclear effective charge, di ba? As we go across, okay, ibalik tayo ha. Tingnan natin. Mula sodium, across a period, padagdag, parami yung number of protons. And ano yung dala-dala ni protons? Positive charge. So, mai-impluwensyahan ngayon yung charge ng nucleus. Okay, take note. Take note. Pag nag-increase yung charge ng nucleus, pag nag-increase yung charge ng nucleus, yung positive charge ng nucleus, or nuclear charge, okay? Okay, for example, ito. Ayan. If yung nucleus sobrang positively charged na masyado, yung nucleus, pa-increase ng pa-increase, yung charge, positive charge niya, that will eventually attract the electrons from the outside more strongly. Di ba? Outside the nucleus may mga electrons. Okay? Therefore, kung parami ng parami, okay, increase yung nuclear charge natin, yung increase yung positive nuclear charge, okay? That will cause attraction sa electrons outside the nucleus. So, ang mangyayari ngayon, pag may attraction, okay? Pag may attraction yan, okay, that will eventually pull the electrons from the outside closer to the nucleus. So, pag na-pull siya inside the nucleus, that will result to shrinking of the atom, decreasing now the size of the atom. Okay? Again, yung main reason bakit nagde-decrease yung atomic size across a period kasi yung nuclear charge, ito, yung nuclear charge increase. Pag increase masyado yung nuclear charge, yung positive charge sa nucleus, okay, higher yung tendency, okay, na yung attraction between this positive charge in the inside and negatively charged on the outside, stronger ngayon yung attraction, leading to pulling the electrons closer to the nucleus, thus decreasing the size of the atom. Okay, that is why again, across a period, atomic radius decreases. Okay, so tandaan nyo, okay, down a group, yung atomic radius increases. Okay, then vice versa, therefore, kung pataas ka, from bottom to top, decrease. So, memorize mo lang yung isang trend. Pag na-memorize mo yung down a group, automatic na yan. Na yung opposite one, pa-decrease. Then, kung period naman, from left to right, okay, decrease yung atomic radius. Okay? Ayan. So, again ha, atomic radius is increases. Atomic radius increases down and left. Okay? Kasi increases man dito. So, pwedeng i-memorize mo lang isang trend. Kasi yung opposite, vice versa, ma-memorize na po nimo. Memorize mo lang yung isang trend, then, alam niyo na kung ano yung opposite. Okay? So given this illustration, kung titingnan natin yung trend, we can say na itong atom na nandito, ito yung largest atom in the periodic table, and that is francium. Okay? Kasi atomic radius increases down and left. Okay? Now, I would like to emphasize the difference between ionic radius from atomic radius. Okay? Again, emphasize ko ha, ano yung difference ng ionic radius sa atomic radius. Okay? So, sabi natin kanina, pag atomic, okay, tingnan ha, pag atomic radius, okay, most of the atoms na nandito, diba, these are non-metals. Ibig sabihin, yung mga non-metals, smaller yung size nila. Kasi smaller yung, decrease yung atomic radius. Okay? And for the metals, sila yung mas may malaking sizes. Okay? So, ayan. Memorize mo lang yung trend. Kahit isang trend lang. Going to the left, going down, increase atomic radius. Fix na yan. Going to the left and down. Okay, that's why naka-diagonal. Down left yung arrow. Okay? So, metals, obviously, medyo larger. Larger yung atom size nila kaysa sa non-metals. But when it comes to ionic radius, okay, tingnan natin. Tingnan natin ngayon ha. Si fluorine isa siyang non-metal. Si sodium isa siyang metal. Okay? Now, during chemical reaction, yung mga atoms, they tend to lose or gain electrons. So, si fluorine as a non-metal, mag-gain siya. Tama? Mag-gain siya ng electron forming an ion. So, ang anion form niya is in a fluoride form, F-. Si sodium naman, during chemical reaction, maglo-lose siya ng electron. Okay? Forming cation. So, yung cation form ni sodium is Na+. Now, pag sinabing nag-add ng electron, nadagdagan siya ng electron, ibig sabihin, kung nadadagdagan siya ng electron, somewhat, mag-i-increase talaga yung size niya. Diba? Mag-i-increase yung level niya. Okay? Kasi madadagdagan siya ng electron sa orbital niya. So, at some point, increase yung atomic radius niya. Not the atomic radius, ionic radius. Kasi we're talking about ions here, charged atoms. Then, whereas yung metal na sodium ion, yung metal na sodium, pag nag-form siya ng cation form niya, ibig sabihin, nag-lose siya ng electron. So, at some point, diba, somewhat like ma-remove, okay, maglo-lose siya ng electron, mawawalan siya ng isang electron. So, kumbaga, nag-decrease yung size niya. Okay, so magkaiba yung ionic radius sa atomic radius. Okay, so please wag kayong ma-confuse, okay, sa dalawa. Okay, basta you have to know the atomic radius. You have to know the atomic radius. Okay, sa periodic trend, going to the left and down, increase atomic radius. Tandaan mo lang dayon nga, basta ions na, okay, ang anion, they gain electron. So, somewhat, nag-increase siya og size. Pag cation, nag-lose siya ng electron, yung cation. Okay, so somewhat, nag-lose, so na-decreasean siya og size. Okay? So, yan po. Then, second, let's have the second property ng elements. Ito yung ionization energy. Ionization energy, ito yung minimum energy na kailangan to remove an electron from an atom or ion in its ground state. Again ha, ito yung kailangan na energy para makapag-remove ng electron. Okay? So, tingnan natin yung trend ngayon. Okay? So, take note, down a group naman, down a group. Ionization energy generally decreases. Okay? Then across a period, ionization energy generally increases. So opposite naman sa atomic radius. Okay? So bakit? Ano yung nangyayari? Okay, say for example ha, si francium. Okay, di ba sabi, down a group daw, down a group, decrease yung ionization energy. Ibig sabihin daw, konti lang, lower lang yung energy na kailangan natin to remove electrons from the outer shell ng francium. Okay, bakit low energy, low ionization energy lang yung kailangan natin to remove outermost electron from francium? Okay, si francium, sabi natin kanina, siya yung largest atom. Tama? So, ibig sabihin, yung kailangan natin na ionization energy required, magdedepende yan sa size ng atom, di ba? If this is francium, ito yung size ng francium, di ba sobra kalaki? Sobra kalaki, ibig sabihin, yung outermost electron malayo sa nucleus. Remember, yung nucleus, okay, meron siyang positive charge. Therefore, kung i-describe natin yung attraction between the nuclear charge and the outermost electron, very weak. Tama? Weak yung attraction. Kasi, sobra ka layo sa distance. Di ba? Di ba? Layo ilahang distance sa nucleus tsaka electrons from the outside. Therefore, kung weaker ang attraction of the nuclear charge towards that electrons from the outermost shell, ibig sabihin, konti lang. Okay, konti lang yung ionization energy na kailangan natin, okay, para ma-remove yung outermost electron. Okay? Then, pag sinabi namang sobrang liit, okay, sobrang liit yung size ng atom, say for example, ayan, example, si helium. Okay? Si helium dito, di ba, pag yung atomic radius, di ba, going to the right, atomic radius decreases. Okay? So, obviously, sobrang liit ni helium. Okay? So, say for example, ito yung atom ni helium, example lang. Okay? Now, ang tanong, ilan yung kailangan natin o magkanong ionization energy? Gaano ka rami yung ionization energy yung kailangan natin para makapag-remove ng electrons, okay, from the outer shell ng helium. Okay? So, since yung sabi nga natin kanina, yung helium, small yung size niya. Okay, dahil small yung size niya, yung tendency, ang nuclear charge, okay, tsaka yung electrons, okay, yung nuclear charge towards the electrons na attraction sobrang strong. Okay? So, stronger ngayon yung attraction kasi sobrang lapit ng nucleus sa outermost shell ng electron. So, stronger ngayon yung attraction ng nuclear charge to the electrons. Therefore, kung strong yung attraction, mahihirapan tayo ngayon to remove electrons. Di ba? Mahihirapan tayo ngayon to remove electrons kasi strong yung attraction, okay, ng nucleus towards the electrons. Kaya yung mangyayari, kailangan dito mag-exert of effort. Okay? So, higher ngayon yung ionization energy na kailangan natin to remove electron. Okay? So, ayan. So, ibig sabihin, again, so opposite ngayon. Diba? Yung trend sa atomic radius. Sa ionization energy, so ito yung tandaan nyo, going to the right, okay, then going up. Diba? Going to the right, going up, increase yung ionization energy. Okay? Yan lang. Yung kanina kasi, going down, going to the left, and going down, yung nangyayari sa atomic radius, nasulat ko dito ha. Again, going to the left, and going down, yung nangyayari sa atomic radius, diba? Increase. Okay? Excuse me. So, ayan. Okay, next. Proceed tayo sa electron affinity. Okay? Electron affinity, obviously, in a period. Okay, bago yan, define muna natin yung electron affinity. affinity. So, electron affinity, ito naman yung energy nga kailangan natin para mag-add. Okay? Mag-add ng electrons to its gaseous neutral atom or in its ground state. Okay? So, the same lang din yung trend sa ionization energy. Okay? So, take note, electron affinity increases up and right. Okay? So, take note, bakit? Bakit yung electron affinity ngayon increases? Going to the right and going up. Okay, why? Sige. That is because, take note, because yung electrons added on the same level, of course, they become much more closer to the nucleus. Tama? Di ba we're talking about the energy na kailangan, okay, or released when an electron is added. Okay, ganito yon. Pag smaller yung size, ng atom, example si helium, di ba smaller yung size ng atom ng helium. Okay? So, ang tendency ngayon, pag mag-a-add ka ng electron, okay? Pag mag-a-add ka ng electron, ibig sabihin, palapit siya sa nucleus. Therefore, palapit siya sa nucleus, magiging much more stronger yung affinity ngayon. Stronger yung attraction, okay, between nucleus and its electrons. Therefore, higher talaga yung tendency ng atom na yan to accept electron. Okay, kaya higher yung electron affinity. Okay, yan yung tandaan nyo. Okay, yan lang yung tandaan nyo. Again. Okay, again. Pag yung size ng atom, smaller size, so example dito, yung mga atoms na non-metals, di ba smaller yung size nila? Okay? Example si oxygen. Okay? Now, yung size ni oxygen, smaller dahil smaller yung size niya, the moment na mag-add ka ng electrons sa iyahang outermost shell, okay, palapit ngayon sa nucleus. So, kung palapit sa nucleus, stronger ngayon yung affinity. Tama? Stronger ngayon yung affinity. So, stronger kumbaga yung attraction between the nucleus, okay? Between the nucleus and its electron from the outside. Therefore, higher yung tendency niya to accept electrons. Okay? So, higher yung electron affinity. Okay? Kasi nga, higher yung tendency niya to accept electrons. Kasi yung attraction magiging much more stronger. Malapit lang kasi yung nucleus sa outermost shell, kung saan nagre-reside yung mga electrons. Okay? So, vice versa, pag sobra kalaki, example kanina, si francium, di ba, sobra kalaki yung atom niya. Therefore, yung nuclear charge dito, malayo sa electron sa outermost shell. So, the moment na mag-add ka ng electron, yung mangyayari, hindi siya masyadong mag-a-accept ngayon ng electron kasi wala naman siyang ka-attraction, di ba? Malayo man yung nucleus sa outermost shell. Okay? So, yan. So, the same lang yung trend pa rin sa electron affinity. Going to the right and going up, okay, increase yung affinity. Okay? So, tatlo na yung na-discuss natin na properties ng elements. So, i-take note nyo yung atomic radius, if this is your periodic table. Ayan. If this is your periodic table, going to the right, ito lang yung trend natin. Going to the right and going up. Kahit ito lang inyo memorize nyo. Kay daghan naman gud kaayo pattern. Depende man gud na sa inyo i-memorize. Okay? So, going to the right and going up. Okay? Ano yung mangyayari sa atomic radius? Atomic radius muna. Again, going up then going to the right. So, decrease yung atomic radius. Ano yung mangyayari sa ionization energy? Ionization energy, increase. Electron affinity, okay, electron affinity, increase. Okay? So, ayan. So, last na tayo na property ng elements. Okay, last property ng elements is yung electronegativity. Okay? Now, electronegativity, this is one of the most important property ng elements or ng atom. Okay? This is actually the ability of the atom to attract. Ability ng atom to attract electrons. Okay? Or shared pair of electrons. Okay? So, tingnan natin yung trend. Okay? Ano yung nangyayari sa electronegativity ng atom? Going up, then going to the right, increase. Okay? So, ayan. Again ha, going to the right, going up, increase din yung electronegativity. Okay? So, yun lang din. The same pa rin yung factors that influences the electronegativity. Okay? Sabi, in a period, di ba? Across a period, increase yung electronegativity. That is because yung number of charges on the nucleus increases. Di ba sabi natin kanina, as we go along the period, okay, mas nag-i-increase yung proton number, so increase yung number of charges ng nucleus. Yung positive charge ng nucleus. And therefore, pag increase yung nucleus charge, that will attract more bonding pairs of electrons more strongly. Okay? So for example, si sodium, okay, ayan. Example, si sodium na 11, yung protons, versus, ayan, si chlorine. Si chlorine na 17, yung protons. Okay, between the two, we suppose na yung chlorine, okay, yung nucleus ng chlorine, higher yung nucleus charge. Nucleus charge positive ha, because of the influence of the number of protons. Dahil higher yung positive nuclear charge niya, higher, okay, yung tendency ngayon, mas madali siyang makapag-attract ng electrons, yung ka-opposite charge niya. Okay, mas madali siyang maka-attract, mas higher yung ability niya to attract shared pair of electrons kasi dumadami yung positive charge niya sa nucleus niya. So, maghahanap talaga siya ng electrons dyan. Okay, kaya very attractive siya ngayon sa electrons. Then, opposite naman, that's across the period ha, across the period. Okay, increase yung electronegativity. Okay, then down a group, yun na nga, dahil farther away, okay, farther away yung mga electrons, okay, so mahihirapan ngayon yung attraction ng nucleus charge towards the electrons from the outside. Okay, because of the distance din, diba? So, ayan. Okay, so tandaan nyo lang ulit yung trend. Sulat ko again yung trend ha. Ito yung pinaka-importante, yung trend. Okay? Periodic table. Ayan. If this is your periodic table again, kahit ito lang i-memorize nyo, going up, then going to the left. Yung isang way lang yung i-memorize nyo. Going up, going to the left, atomic radius. Okay? Bababa. But the rest, ionization energy, electron affinity, then electronegativity, okay? increase. Yan. So, ibig sabihin, kung vice versa naman, pag vice versa, yung i-memorize, kung going to the left naman, okay? So, kung papunta ka sa left, pa-down ka, opposite na yung mangyayari dito. Diba? Opposite na. Ibig sabihin yung atomic radius tataas, okay? Ionization, electron, affinity, electronegativity, bababa. Okay? So, depende sa inyo kung ano yung i-memorize nyo na trend. Kasi pag alam nyo yung isang trend, okay, yung isang way ng trend, malalaman nyo din yung vice versa niya. Okay? So, ayan. Now, let us proceed to chemical combination. Okay? Chemical bonds or the chemical combination. Now, when we say chemical bonds, ito yung attractive force between two ions or between two atoms. Again ha, yung isang bond, it is only formed between two ions or two atoms. Okay? So for this given molecular structure, yung model na molecular structure na presented, ilan yung chemical bonds? Di ba? Merong isa, dalawa, tatlo, then apat. Okay? So ayan. So again, per bond, formed lang siya between two atoms or two ions. Okay? Now, yung chemical combination po, yung chemical combination na concept, this is very important. Okay? Very important din siya among atoms. Why? Para ma-attain nila yung octet rule. Okay? Again, yung chemical reaction na thought that is very important among atoms, okay, or yung chemical combination, para ma-attain nila yung octet rule. Ibig sabihin ng octet rule, yung atoms attains 8 electrons in its valence shell, or na-attain niya yung completely filled na orbital. Ibig sabihin, stable yung electron configuration. Okay, so say for example, si chlorine. Diba si chlorine, yung atomic number niya is 17, so equivalent yan to 17 number of electrons. Kasi for a neutral atom, equal lang naman yung number of protons sa number of electrons. Okay? So, kung isusulat natin yung electronic configuration ng chlorine, neutral chlorine, diba, that is 1s2, 2s2, okay, 2p6, 3s2, and 3p5. Okay? Now, tingnan, sa highest n value niya, okay, sa outermost shell niya, merong 7 occupying valence electrons. Therefore, kulang ng isa para ma-attain niya yung octet rule, yung 8 electrons in its outermost valence shell. Okay? So, yung mangyayari ngayon ni chlorine, that is why during chemical reaction, kailangan niyang mag-gain ng isa pa. Diba? 7 man to. So, kulang ng isa sa p orbital. Diba? 6 yung maximum number of electrons na ma-hold ni p orbital. So, kulang siya ng isa, kaya mag-gain siya ng isang electron during chemical reaction. So, yung mangyayari from 17, magiging 18 yung number of electrons. So, kung isusulat natin yung electron configuration ngayon, stable na. Diba? Completely filled na yung atomic orbital niya. Okay? So, 2p6, 3s2, and 3p6. Ayan. So, in this case, na-attain niya yung stable or completely filled atomic orbital. Di ba? Completely filled na atomic orbital, specifically, the same with argon, na stable atom. Okay, so parehas na sila ngayon ng electronic configuration ng argon. So, that is the importance ng chemical combination. Bakit very important sa mga atoms yung chemical combination para ma-attain nila yung stable electron configuration. Okay? Now, when we talk about chemical bonds, there are two. There are two types of chemical bonds. We have the ionic bond, tsaka covalent bond. Okay? Now, yung ionic bond, yung ionic bond, this is formed by attraction between ions of opposite charge. Naalala yung ionic compound? O, parang ganun. Yung ionic compound, di ba, nabubuo upon interaction of a cation plus an anion, so opposite charge. What particular bond composes an ionic compound or ionic bonds? Okay? So again, yung ionic bond, nabubuo siya by attraction between ions of opposite charge. Yun yung ions, tsaka ions. Kasi opposite charge, positive, tsaka negative. So most of the atoms that interacts forming ionic bond is yung metal, non-metals, okay? So ionic. Or pwede ding metals plus metalloids kasi yung metalloids meron siyang non-metallic property. Then metalloids plus non-metals kasi yung metalloids din meron siyang metallic property. So for this column, ito yung mga atoms that loses electrons. Pag nag-lose ng electrons sila, yung tendency na nag-form ng ions, naalala? Cat ions, yung nag-lose ng electrons. Then atoms that gains electrons during chemical reactions, sila naman yung anion. So overall, nabubuo talaga yung ionic bond upon interaction ng cation tsaka anion. Okay? So example. Okay, example tayo. Ngayon, we have sodium. Okay, example is sodium. Okay. Si sodium po, sa sodium chloride, okay, sodium plus chlorine. Okay. So, kung titingnan natin, yung sodium as the cation interacts with anion. Okay. So, ibig sabihin, once na-form yung compound na sodium and chloride, itong bond na to is an example of ionic bond. Okay? The same thing with magnesium. Ganon din yung mangyayari. Okay? So, try drill ko na. Okay. Yung magnesium, ganon din. Di ba yung magnesium is a 2+. Okay? Na pag interacting with chloride, ngayon, ganun din yung mangyayari. Cation, anion, interact. So, magnesium, okay? Yung chloride, ayan, yung chloride. So, itong bond na to, this is an ionic bond. Okay? So, forming the magnesium chloride. So again ionic bond, this is formed by attraction between ions of opposite charge. Okay, the other type of bond is the covalent. Okay, yung covalent bond naman, this is formed by sharing electrons. So this time nag-share ng electrons. Walang nag-lose, walang nag-gain, nag-share lang sila ng electrons. So this is formed between non-metals to non-metals. So example, ito, chlorine to chlorine. Diba? Non-metals to non-metals. So these are examples. Okay, the bond that forms between chlorine, between hydrogen here, between hydrogen and chloride, these are examples of covalent bond. Nag-share lang ng electrons. So yung clue natin dito is non-metals to non-metals siya. Okay? So ayan. Now when we talk about covalent bond, okay, which is formed by electron sharing, okay, naa siya duha ka types. Natay duha ka properties or duha ka types of covalent bond. Pwede siya either non-polar or polar covalent bond. Pag sinabing non-polar covalent bond, okay, nagkakaroon dito ng equal sharing of electrons. So equal ang pag-share sa electrons ng dalawang atoms. And take note, bakit nagkakaroon ng equal sharing? Because the bond is formed between identical atoms. Okay? But, pwede din naman siya mangyari sa non-identical atoms as long as the electronegativity difference is between 0 to 0.4. Okay? So, Obviously, ito, identical atom, carbon to carbon. So, yung bond between that is a covalent type of bond, specifically a non-polar bond kasi nagkakaroon ng equal sharing of electron. Okay, try natin kunin yung electronic difference, electronegativity difference. Kasi yan yung pinaka-evidence natin na non-polar yung isang bond. Kung polar ba o non-polar, kunin natin yung electronegativity difference. Okay? So again, pag na-fall in this range, 0 to 0.4, yung electronegativity difference, ibig sabihin, non-polar yung covalent bond. Okay? So carbon po, kung titingnan nyo sa periodic table, electronegativity ng carbon is 2.5. So kunin mo daw yung electronegativity difference, okay, so 2.5 minus 2.5. Okay? So ito yan. Ayan. So, 2.5 minus 2.5, 0. Diba? Kaya nga, equal lang yung share, yung pag-share ng electrons. Okay? So, ayan. So, yan yung mangyayari sa, basta identical yung atoms, 0 talaga yung makukuha mong electronegativity difference. So, no question, yan na yung non-polar covalent bond. Pero again, pwede din mag-exist yung non-polar covalent bond between non-identical atoms na nag-bond. So say for example, carbon and hydrogen. Bakit na-belong siya or considered siya as non-polar covalent bond? Because, again, yung electronegativity difference niya is between 0 to 0.4. Try natin kunin ha. Si carbon, again, carbon, 2.5 yung electronegativity difference minus si hydrogen. Ano yung electronegativity difference? 2.1. Nasa periodic table to ha, yung electronegativity. So, kunin mo lang yung difference, 2.5 minus 2.1, di ba? 0.4. Okay? So, ganun din yung kay carbon tsaka bromine. Although, hindi sila identical atoms, pero yung bond that forms in between carbon tsaka bromine here is a non-polar one. Sige, try natin ha. Again, 2.5 yung carbon minus si bromine. Tingnan nyo sa periodic table. Bromine is 2.8. Okay, therefore, yung makukuha mong electronegativity difference is 0.3. Okay, so ayan. So these are examples of non-polar covalent bonds. So tandaan nyo lang, non-polar, okay, non-polar, nagkakaroon ng equal sharing of electrons. Okay, equal yung sharing of electrons, and this is most commonly formed when identical atoms bond together. Then, yung electronegativity difference is between 0 to 0.4. Kaya hindi nyo kailangang i-memorize yung electronegativity. Okay, given naman yan. Okay, hindi kailangan i-memorize yung electronegativity. Basta alam mo lang mag-minus. Okay, kung makukuha mo yung electronegativity difference, i-apply mo lang yung concept na basta yung electronegativity difference is between 0 to 0.4, that is considered non-polar covalent bond. Okay. Then, ayan. Then the second type of covalent bond, pwede din siya polar, pwede naman polar, covalent. Mas pag sinabing polar, so opposite na ngayon ng non-polar. So polar, meron ng dalawang poles na nabuo. Okay, yung isang pole positive, yung isang pole negative. Okay, so pag polar, nagkakaroon ng unequal sharing of electrons. So, higher ngayon yung electronegativity difference. So, hindi masyadong equal yung pagka-share. Di ba pag sinabing covalent bond, nagkakaroon ng sharing of electrons. So, pag sinabing polar covalent type of bond, yung electronegativity difference ngayon, mataas kasi nagkakaroon ng unequal sharing of electrons. Okay? Mas grabe yung pull ng isa sa electrons kaysa sa isa. Okay, so these are examples of compounds wherein nagpo-form ng polar covalent bond. So say for example, si hydrogen towards chlorine. Itong bond na daw ito is an example of polar covalent bond. Okay, try natin i-check yung electronegativity difference. Electronegativity difference. Okay, so yung hydrogen po is 2.1 again. 2.1 yung electronegativity niya. Si chlorine, tingnan niyo sa periodic table, di ba? It is 3.0. So, kung kunin mo yung electronegativity difference, 2.1, 3.0, that is 0.9. Tama? 0.9. So, 0.9 yung electronegativity difference. So, mafo-fall siya between this range. So, isa siyang polar covalent bond. Okay? So, ayan. Now, talking about the polar covalent bond, itong pair of shared electrons between a polar covalent bond, that can be shown, take note, that can be shown as a line between two atoms. Okay? So again, balik tayo ha. Again, yung shared electrons, yung pair of shared electrons dito, that can be shown by a line, okay, between two atoms. So, yung line na yon, ganito po siya isulat. Okay? Ganyan. Ibig sabihin, kung saan nakatutok yung arrowhead, ibig sabihin yung atom na yan, siya yung much more electronegative. Then, kung saan yung tail na may positive charge, siya yung hindi masyadong electronegative. Okay? Which makes sense, di ba? Pag positively charged, hindi naman talaga siya masyadong electronegative. Again, kung saan nakatutok yung arrowhead, that indicates a more electronegative atom. Okay, so this particular line, this indicates dipole moment. Okay, dipole moment. Ano yung dipole moment? Dipole moment, that's a measure of polarity of a bond. Again, that is a measure of a polarity of a bond. Ibig sabihin, pag mataas, sobrang taas yung dipole moment, pag mataas yung dipole moment, the higher is the electronegativity difference. Ito, since higher yung electronegativity difference between hydrogen at chlorine bonded together, ibig sabihin, mataas din yung dipole moment. Okay? Now, with this line represented, masasabi natin na si chlorine dito siya ang much more electronegative. Obvious man sa electronegativity values. Diba? Si chlorine, 3.0. Si hydrogen, 2.1 lang. So, higher yung electronegativity ni chlorine, making it much more electronegative. That is why, si chlorine yung partially negative, si hydrogen naman yung partially positive. Okay? More electronegative yung chlorine kaysa ni hydrogen. Okay? Another example. Si ammonia. Okay? Si ammonia, yung bond daw, lahat ng bond present in ammonia, specifically bond between nitrogen and hydrogen, these are example of polar covalent bond. So, nagkakaroon ng unequal sharing of electrons. Okay? So, try natin kunin yung electronegativity difference. So, si nitrogen, tingnan nyo sa periodic table, 3.0 din. Same with chlorine. Okay? Then, yung hydrogen ulit, 2.1. Okay? So, kung kukunin mo ulit yung electronegativity difference, 0.9 ulit. 1 point. Hindi 0.9. 1.9. Okay? 1.9 pala. Yung kanina, 1.9. Tama ba? Oo. 1.9. Okay? So, take note ha. Yung electronegativity difference kanina ni hydrogen to chlorine, it's 1.9. Okay? 0.9 lagi. 0.9. 0.9. Okay, tama pala. Tama yung kanina, 0.9. Okay? So, ganun din dito, 0.9 din. Okay? So, higher yung electronegativity difference. So, isang polar covalent bond between nitrogen tsaka hydrogen. Okay? So, kung atong i-apply yung dipole moment na line, saan papunta ngayon? Yung arrow. Okay? Ibig sabihin, for hydrogen towards nitrogen, yung dipole moment is going towards nitrogen. Okay, ganun din dito. Towards nitrogen. Ibig sabihin, again ha, kung asa nakatutok yung arrowhead, siya yung much more electronegative atom. Kung asa yung tail na positive, siya yung less electronegative. So, ganun din dito. Okay? So, partially positive si hydrogen, ito yung partially negative si nitrogen. Okay? So, again, the bonds that is formed in the compound ammonia are polar covalent bonds. And lastly, ganun din sa water. Okay? Diba yung water? So, O, then H2. O, then H, H. Okay? So, ayan. So, observed, again, na yung bond, meron tayong dalawang bonds in between hydrogen and oxygen. Ganun din dito, between hydrogen and oxygen. Tingnan natin kung polar ba talaga yung type ng covalent bond. Okay, dito. Sige, kunin natin yung electronegativity difference ulit. Yung hydrogen ulit, 2.1. Yung oxygen is 3. Okay, 3.5. Ganun din sa kabila. Diba? 2.1 and then 3.5. Okay? Ayan, 2.1. Okay? So, check nyo ha. I-check nyo sa periodic table kung 3.5 ba talaga yung oxygen na electronegativity. Okay? So, kung kanina, i-compare mo yung nitrogen, much more electronegative ngayon si oxygen. Okay? So, kunin natin yung electronegativity difference. 3.5 minus 2.1, di ba? That is 1.4 ba? Diba? 1.4. Okay? So, again, yung electronegativity difference na makukuha natin dito is 1.4. So, sobra kalaki na electronegativity difference. Okay? So, isang polar covalent bond each. Okay? So, ayan. Then, kung titingnan natin yung dipole moment, papuntang oxygen. Kasi, si oxygen, obviously, tingnan natin yung value, di ba? Tingnan yung value ng electronegativity, higher yung kay oxygen. Much more electronegative siya. Then, yung hydrogen, less electronegative. So, ayan. Okay. So, those are the two types of covalent bonds. The nonpolar at saka polar covalent bond. So, pwede nating malaman kung nonpolar or polar via its electronegativity difference. Pag yung range is 0.5 to 1.7, yan yung polar. Pag below 0.4 below, yan yung non-polar. Okay, so example tayo. Which among the bond is more polar? Okay? So, atong i-compare per set, pipili tayo. So, ang bond between the two is more polar. So, between carbon daw and hydrogen, between chlorine and carbon, sa ang bond dito ang much more polar. So, you can apply the concept ng electronegativity difference. Kunin mo yung electronegativity difference ng each. Okay? Each bonded atoms. Okay? So, kanina sabi natin, si hydrogen is 2.1. Okay? Then, si carbon is 2.5. Okay? So, 0.4 yung makukuha mong electronegativity difference. Kung 0.4 na, remember, 0.4 yung makukuha mo. Kung 0.4, hindi naman yan polar, di ba? 0.4 below, nonpolar. So, automatic, ito na yung much more polar bond. Okay? Sige, next. Sa letter B na set, between hydrogen to oxygen bond and hydrogen to hydrogen. Naalala, basta identical atoms nag-bond together, kung kwaon mo ang electronegativity difference, 0 ang imuhang makuha. Kaya the same man. Example, 2.1 din eh. 2.1. Kung imong kwaon ang electronegativity difference, 0 gyud. Okay? So, dili ni siya polar. Kasi isa siyang non-polar covalent bond. So, automatic, ito na yung sagot. Okay? Then, letter C. Between hydrogen and chlorine na bonded atoms, then hydrogen, then fluorine na bonded atoms. Sino yung much more polar? Okay. So, parehas lang na hydrogen. So, 2.1. Nandito 2.1. So, tingnan ngayon yung electronegativity ni chlorine. Chlorine is 3.0. Fluorine is 4.0. So, higher yung electronegativity ni fluorine, therefore, mas malaki yung electronegativity difference na makukuha natin dito. Okay? So, ito yung much more polar. Okay, then lastly, ganun din. The same lang yung gagamitin nyo na technique. Okay? Dahil yung given, chlorine to chlorine, so obviously, to siya, non-polar bond. Kasi nga, yung makukuha mong electronegativity difference is 0 pag i-minus mo yung electronegativity value. So, hindi na yan polar. Non-polar na yan. So, automatic, ito yung polar bond. Okay? Sige. Okay, last slide. Last sample problems. Last sample problems. Sabi, use the symbols partially positive and partially negative to show the direction of polarity. So again, partially positive lang and partially negative. Okay? Para mag-indicate ng direction ng polarity. So say for example, in the given example, yung hinighlight nga bond is between carbon tsaka oxygen. So dito lang kayo mag-focus between carbon. Neglect this one. Neglect this one. Ito lang man yung tinatanong. Okay? So yung bond daw between carbon tsaka oxygen, okay, lagyan mo ng symbol na partially positive. Sino yung partially negative? To show the direction of polarity. Naalala, yung partially negative, siya yung much more electronegative atom. Yung partially positive, siya yung less electronegative atom. Paano natin malalaman kung more electronegative or less electronegative? Yung electronegativity value. Or, balikan yung trend. Okay? Di ba yung trend sa electronegativity going to the right, increase. Going up, increase yung electronegativity. So that is why, yun na nga, kahit wala kayong periodic table sa harap, kung alam nyo kung saan malolocate yung, in general, yung atom, pwede mong ma-analyze kung sino yung partially negative, sino yung partially positive. Ibig sabihin, sino yung more electronegative and less electronegative. Try natin na hindi gumamit ng electronegativity values. Okay, yung periodic table lang. Imagine natin, blank na periodic table. Pero alam natin na yung trend, going to the right, going up, increase yung electronegativity. Okay? Kasi pag siya yung may higher electronegativity, ibig sabihin siya yung partially negative. Okay? Now, so say for example, in the given example, first one, between oxygen and hydrogen. Sino ngayon yung partially negative? Sino ngayon yung partially positive? So, oxygen, imagine, di ba si hydrogen andito? Alam natin na si hydrogen andito. Then, somewhat nandito si oxygen. Tama? Nandito siya sa right side. Therefore, higher electronegative ngayon si oxygen. So, sa yung partially negative. Si hydrogen partially positive. Okay? Next, letter B. Between carbon, neglect this one ha, kasi hindi sila yung in-emphasize. Okay, between nitrogen lang, kung saan yung bond, ibig sabihin yun yung gi-ask. Ano yung klaseng bond between that or sino yung partially positive pole or negative pole sa dalawa. Okay? Carbon and nitrogen. Naku ma'am, carbon and nitrogen, diri man namo ni makita. Okay? Okay lang. Kasi, di ba? Although diri sila nakita, pero hindi sila parehas ng group. Tama? Si carbon yung mauna ay yung nitrogen. Okay? So, given this, kung carbon ang una ay nitrogen, going to the right, increasing. So, mas higher electronegative yung nitrogen. That's why siya ang partially negative. Carbon is partially positive. Okay? Ganon din kay oxygen, tsaka bromine. Si oxygen kasi andito. Si bromine nasa baba. Okay? Oxygen nandito, si bromine sa baba. So, given this trend, sino ngayon yung higher electronegative? Higher yung electronegativity, oxygen or bromine? Oxygen or bromine? Oxygen or bromine going up? Tama, si oxygen. So, partially negative si oxygen, partially positive si bromine. And lastly, iodine and chlorine. Si iodine, chlorine, okay, parehas ng group. Okay, fluorine, chlorine, iodine. Nandito yan. So, chlorine, then iodine dito. Therefore, kinsa ang higher electronegative? Chlorine nga nasa taas or iodine nga nasa baba? Di ba? Going up, increase yung electronegativity. So, negativity mas higher yung kay chlorine, then partially negative si iodine.